right, welcome. Today we are going to be on lesson 9.1, which is page 357 in your book, if you have it. Today we're going to talk about independent and dependent variables. And specifically, we're going to cover this essential question and be able to answer this by the end of the lesson. How can you write an equation to represent the relationship between an independent variable and a dependent variable? So let's review a little bit of vocabulary here first. What is a variable? A variable is a letter that holds the place of a number in the equation because that number is going to change. And because it changes, we can't assign a number to it. So we just give it a letter to hold that place. All right, dependent variable, let's talk about that first. Dependent means that it relies on or needs something else. Independent influences or controls the dependent variable. So let's read this paragraph. It says, you can use an equation with two variables to represent a relationship between two quantities. One variable is called the independent variable, and the other is called the dependent variable. The value of the independent variable determines or controls the value of the dependent variable. So let's think of some more examples of independent and dependent. So here's an example. Okay. A baby is dependent on adults for everything that it needs. It relies on the adult. So in this example, the baby is the dependent variable and the adult is the independent variable. So let's think of another real life situation. If a caterpillar depends on the amount of leaves that are available for it to eat. So the dependent variable is the caterpillar. The leaves are the independent variable. Let's take you outside for another example. That's crazy. All right, so let's go ahead and get started on our lesson in the book now that we understand the difference between independent and dependent. All right, Jerry burns 5.8 calories for every minute she jogs. Identify the independent and dependent variables in this situation. Then write an equation to represent the relationship between the number of minutes Jerry jogs and the total number of calories she burns. So first we have to identify the independent and dependent variables. Then use the variables to write an equation. Let C represent the number of calories that Jerry burns. Notice that they used C because it starts with the word calorie starts with a C. Let M represent the number of minutes Jerry jogs. So this is where they found the independent and dependent variables in the story problem. The total number of calories Jerry burns depends on the number of minutes she jogs. Blank is the dependent variable. Blank is the independent variable. Now think about that for a second. Which variable is influencing or controlling the other one? The one that's in control is how many minutes she's running, because the more minutes she runs, the more calories she's going to burn. Therefore, minutes is your independent variable. Calories depends on how many minutes she's running. Write an equation to represent this situation. All right, the total calories burned, which is C, is equal to 5.8 times the number of minutes jogged, which is M. So these are our two variables. So the equation C equals 5.8 M, or C equals 5.8 times M, represents the number of calories. Remember, this is a little more mathematically mature way of writing 5.8 times M. This is fine too. They mean the same thing. All right, Jerry burns, represents the number of calories Jerry burns if she jogs M minutes, where C is the dependent variable and M is the independent variable. All right, turning the page to page 358, here's our next example. Lorelei is spending the afternoon bowling with her friends. Each game she plays costs $3.25, and there is a one-time shoe rental fee of $2.50. Identify the independent and dependent variables in this situation. Then write an equation to represent the relationship between the number of games and the total cost. So first, think the total cost in dollars. C depends on the number of games G Lorelei plays. So which one is depending? Well, they've already told us that. It's C depends on the number of games. So our dependent variable then is C. The number of games Lorelei plays is the independent variable, G. So the total cost, C, is, which means equals, the cost of a game, which is $3.25, times the number of games, which is G. We don't know how many games she's going to play yet. She might get tired after one game. She might want to play 4 games. We don't know yet. So that's why we're not writing a number. We're using a variable instead. Plus the shoe rental. Now in this case, the shoe rental is a one-time fee. So when she rents those shoes, she doesn't have to rent them for every single game. She just rents them once, and then she can use them for the rest of the time that she's there. So this is a fixed cost. It doesn't change. It doesn't need a variable. So this was $2.50. So a one-time fee is just added to the end of our equation and doesn't get assigned a variable. So we're going to take all of these factors and put them all together on this line here. So the equation C equals $3.25 times G, and putting it right next to G means that we're multiplying, plus the $2.50 shoe rental fee represents, let's move this up, the total cost in dollars C that Lorelei spends if she bowls G games. We don't know how many games. It might be 1 game, it might be 5 games, we don't know. Where C is the dependent variable and G is the independent variable. All right, so now we're going to use this equation that we created up here. Notice how they wrote it without the multiplication sign in between. Find the value of C, or the total cost, when G is 3. So that means she played 3 games. So first we write the equation, which they did for us. Substitute 3 for G. In other words, we're going to put 3 right in there for that variable. C equals $3.25 times 3 games plus $2.50 for that shoe rental. Follow the order of operations to solve for C. Well, according to order of operations, as you'll recall, we do multiplication before we do addition. So we're going to take care of this operation first. And we're going to do a little margin work over here. Remember, margin work is great. And we don't erase it because then the teacher can see everything that's going on in our brain. So $3.25 times 3. 3 times 5 is 15. And regroup that 1. 3 times 2 is 6, plus 1 more is 7. Don't have to regroup that time. 3 times 3 is 9. Okay, so we're done with our multiplication. Now we look to see how many digits are behind the decimal. We have 1, 2 behind the decimal up here. We don't have any down here, so we have a total of just 2 digits behind the decimal. So we go 1, 2, then that's where our decimal goes. So it cost $9.75 to play 3 games. Plus that $2.50 that she paid when she walked in the door to rent those shoes. So we solved for C, which is 9.75 plus $2.50. Now again, I'm going to do a little margin work because I want to line up my decimals, because with addition and decimals, you have to line up the decimals. See how these are stacked on top of each other? 5 plus 0 is 5. 7 plus 5 is 12. Regroup the 1. 1 plus 9 is 10, plus 2 more is 12. And bring that decimal straight down. So the total cost for her games that day was $12.25. So it will cost Lorelei, we'll put our dollar symbol there, $12.25 to play 3 games. Okay, let's take a look at these problems down below. What if there were no fee for shoe rentals? How would the equation be different? Well, if we look at our equation up here, C equals $3.25 times the number of games Lorelei's going to play. This would be eliminated. So their total cost would equal 3.25 or $3.25 times 3 games. And what does that equal? $9.75. All right, let's evaluate reasonableness. So, how can you use estimation to check that your answer is reasonable? So, sometimes when we see decimals in our problems, they make us a little bit nervous. So, in order to determine whether or not your answer is in the ballpark of being correct, Sometimes you can just look at numbers, round them to the nearest whole number, and that will give you a good idea of whether or not your answer is pretty close to right. So let's round off our the numbers in our equation and try this again. So let's make it C equals, and 3.25 is closer to 3 than it is 4. So we're going to say 3G plus, and 2.5 is actually closer to 3 than 2, so we're going to put 3. So that's our estimation part. So if we're going to substitute in 3 for that G, we would have C equals 3 times 3 plus 3. And again, using our order of operations, we're going to do this operation first because multiplication comes before addition and subtraction. 3 times 3 is 9 plus 3. C equals 12. And our final answer up here, using our decimals and doing the problem completely, was 12.25. So, is our answer probably correct? Yes, because our estimation was 12 and our final answer was 12.25, which if you rounded that to a whole number is also 12. We probably have the right number. So that's how we use an estimation to check that our answer is reasonable. All right, moving on to page 359. In our books, let's move on to the share and show section of our lesson. And it says, identify independent and dependent variables, then write an equation to represent the relationship between them. So this is it. We're now down to what our lesson wants us to be able to do by the end of our time together. We should be able to write an equation to represent the relationship between our dependent and independent variables. An online store lets customers have their name printed on any item they buy. The total cost, C, in dollars, is the price of the item, P, in dollars, plus $3.99 for the name. Okay, notice something here. When it says total, that tells us that that depends on this variable. So this is our dependent variable. This is our independent variable. Anytime we see that word total, that's a big clue, and we're going to write that in our notes, that this is our dependent variable. So the cost, the total cost depends on the price, plus that $3.99 for the name. So this is a fixed one-time fee right here. All right, so our dependent variable is C for cost. Our independent variable is P for the price. All of these are in the same unit, which is dollars in this case. So now we need to write our equation. So the equation is C, because that's our dependent variable, and that's what goes out front all by itself is the dependent variable. That's what stands alone in the equation. Then we go find our independent variable, which is P, and here they use the word plus, which tells us our operation. Remember, there's only 4 operations: multiplication, division, addition, and subtraction. And since they told us the operation, they made our lives easy there. So we go 3.99 or $3.99. So there's our equation. The total cost equals the price plus the $3.99 they charge us for the name. All right, number 2. A raft travels downriver at a rate of 6 miles per hour. The total distance, D, in miles that the raft travels is equal to the rate times the number of hours. So right here, they're telling us something, aren't they? They're telling us our operation that's going to be in our equation is times. Per also means times. So right there, we know we're going to be using that operation. All right, let's figure out what our dependent variable is. Oh, look at that key word. Showed up one more time. The total distance, D, in miles that the raft travels is equal to the rate times the number of hours. So how long they travel. So this is our dependent variable. Because of this word total, we know it's our dependent variable. It depends on the number of hours that they have to float down that river on their raft, right? Okay, so our dependent variable is D. Our independent variable is H. So this is distance. This is hours. And we know that we're using this operation, which is times. But what are we going to times it by? Let's look back in our problem and see if we can find a number. Oh, look at that, 6. 6 times the hours will give us our distance. So we put our dependent variable out first, and we're going to include this in our notes at the end. Dependent variable goes out first. D equals, and we know it's times, we're going to go 6 times H, 6H. Now we could have written it like this, D equals 6 times H, and that's fine. It's correct, but this is better. This is the more mathematically mature way of writing that equation. Here we go again. Let's see if we can find our dependent and independent variables. So we're going to look for the word total and see if we can find it. Oh, look at that, total. So they're going to make our lives easy to find that dependent variable. Here we go. Apples are on sale for $1.99 a pound. So this is the same as that word per over here, and that tells us what operation is going to be happening. Times. All right, so apples are on sale for $1.99 per pound. Sheila buys P pounds of apples for a total cost of C dollars. So our total cost of C dollars, this tells us our dependent variable. All right, the independent variable, the one that controls the cost, is how many pounds we buy. P pounds. And we don't know how many pounds Sheila's going to go buy. She might buy 10 pounds. She might buy 1 pound. Maybe she has a big family or a party coming up and she needs to buy 15 pounds of apples. I don't know that part, so that's why we use a variable instead of a number. All right, now let's write our equation. The first thing we do is we put down the dependent variable first. Our dependent variable equals whatever's happening with the independent variable. So we have C equals, and we know it's multiplication, 1.99, got that from right here, that's where our number came from, P times P, or you could have written it like this, and that's okay, but this is more mature. This shows us that you're more mathematically mature, because this implies that you're multiplying without even using the symbol. All right, so now you're on your own for the next part of the lesson. You complete the on your own part. Next, I'll be showing you the notes for this lesson, and then finally at the end, you may do the personal math trainer, the PMT that's been assigned to you. All right. All right, so as we copy down our notes, I'm going to narrate them first. At any point in time, you can pause this video on your device and go as slow or as fast as you want through the lesson. You can go back and review anything that didn't make sense the first time. So if you feel like I'm moving too fast, that's okay. You can pause and get your notes written down. All right, so 9.1, independent and dependent variables. So on this side, we're going to write our notes. On this side, examples. First, we begin by finding the dependent variable. Always begin with that because that's the easiest part. The dependent variable depends on the amount of the independent variable. Remember the gas in the truck at the beginning of the lesson. How much gas we put in, that's our independent variable, will tell us how far I can drive that truck. That's the dependent variable. Find the dependent variable first. Okay, hint, we talked about this during the lesson. Cost or total will often be the dependent variable, almost always. So keep that in mind. That just makes your life so much easier. If you see total cost next to the variable, that's probably your dependent variable. If there is a fixed cost or a one-time fee, like the shoe rental or adding the name to the shirts, it is added at the end of the equation. All right, so here's some examples of some dependent and independent variables. When we began the lesson, the baby is dependent on its adults. The caterpillar was dependent on the leaves. How far I can travel in the truck depends on the gas. So these are the dependent variables. These control what's going to happen over here. All right, so let's take a look at a problem that we can put in our notes. Once again, you can pause if I'm moving too fast. Byron is playing a game. He earns 10 points for each treasure box he opens. His total score, S, that's our variable, equals the number of treasure boxes, T, for treasure boxes, times 10. Now look at that word total, and it's connected to the S. So that tells us that the S is our dependent variable. His score depends on the number of treasure boxes he opens. Treasure boxes are T, that's our independent variable. So our equation is wrong. Okay, so as I was writing these out last night, I went too fast and I made a mistake. So it's time to fix it. Okay, the dependent variable goes out front, which is S. S equals 10 times T. So his score equals how many treasure boxes he opens times T, or 10 times T, to remind us that that's the operation that's happening, multiplication. All right, the dependent variable is the alone one on the side of the equation. So that's our dependent variable out there. You'll notice I messed that up. We all make mistakes. That's okay, as long as we fix them. All right. Hint. Go back and use your keywords worksheet in lesson 7.3 notes to help you write the equation. So, if you'll recall, these words will help you write the equation because they remind you of what operation is happening. And I wrote in a couple extras. Per, for each, that means multiplication. So I went ahead and wrote in a few extra notes. Here's another thing I wrote in. Equal, when I see the word is, that means equal. Okay, so remember these words that we used in 7.3. All right, and for each, every, per, they all mean multiply. And then we can glue in our reteach notes. I'm going to have to redo that. There we go. And we glue in our little reteach page for Mom and Dad to help us when we're asking for help with our homework. All right. Okay, so that is it for lesson 9.1.